In example 8, we're going to talk about how to match slope fields with differential equations. So the first one we're going to look at is dy dx equals x minus y. Notice that there are two variables in this differential equation. Now I want to solve this without having to actually solve the equation. So let's just think about some points in our head. For example, for the first one, let's look at the points 1, 1, 2, 2, -1, -1, and 2, -2, -2. So dy for this one, dy dx, is going to be equal to 1 minus 1, so that's 0. So on the graph, at 1, 1, the slope should be 0. At 2, 2, we'll get 2 minus 2, so that's also 0. Here we're going to get -1 minus -1, and -2 minus -2. Each of these I get 0. This means on the graph, the slopes at these values will be 0. So if I were to graph this by hand, at 1, 1, the slope would be 0. At 2, 2, the slope would be 0. -1, -1, the slope would be 0. And at -2, -2, the slope would be 0. If I actually graph this, though, the entire slope field, which is x minus y, I get this as my slope field. This is my entire slope field. I know it looks a little confusing at first, but if we go ahead and look at it, you'll see that at 1, 1, the slope is 0. At 0, 0, the slope is 0. At 2, 2, the slope is 0. You can see how they start to take shape. The reason this looks all kinds of weird is if, for example, say I plot 4, 3. I'm going to plot this point right here. So I'm going to use the point 4, 3, and it was dy dx is equal to x minus y. So this gives me 4 minus 3, which is 1, which means right here the slope should be 1, which is what it is. So a slope field is made by plugging in x and y values and determining slopes at a given value. So if you're given some functions and some slope fields, all you need to do is test them and see which ones work. So if I try another one, for example, say I try x times y. Let's get rid of this. So what's unique about this graph right here is that there's slopes at 1 minus 1, 2, 2, -1, -1. So what I want to notice about this is when x equals y, the slope, or dy dx, is equal to 0. Number 2, when x times y. So in this example, for part 2, we want to look at when x times y equals the slope. So if I pull up a graph of these, so if I want to find a slope field of xy, it's going to look something like this. So this happens because near the center right here, notice that it's pretty much 0 because when you plug in 0, you get 0. So anything along these axes are going to be 0. Anything along this axis is going to be 0. As you start pushing away, the numbers are going to get large very fast because they're multiplying. Notice that all the slopes in here are positive because it's a positive and a positive. All the slopes here are negative, see they're going down because it's a negative and a positive. Here they're down because it's a negative and a positive. And here they're positive because it's a negative and a negative. So for xy, we want to look for slopes of 0 at the x and y axis. And if you look at a graph, you'll notice that these are positive, these are negative, these are positive, and these are negative. Now let's look at x divided by y. So right off the bat, we know that if x equals 0, then dy dx is equal to 0. If y is equal to 0, then dy dx is undefined. Well, if that's the case, this is going to be a straight up and down line. This is going to be a sideways line. So let's see what that graph actually looks like. So I'm going to type in a slope field of x over y. And you can see along the y-axis, the y-axis, you get that the slopes are 0. And along the x-axis, the slopes are going to be undefined. And for the last one, y over x, it's just going to be the reverse. So if x equals 0, dy dx is undefined. If y equals 0, dy dx is 0. So let's look at a slope field with that. And we're going to get y divided by x. And you can see how around the x-axis, the slopes are 0, and around the y-axis, the slopes are undefined. If you would like to determine these values in the quadrants, all you have to do is pick an x, pick a y, and plug them in and then plot the slopes.